to this paper. And we can do this question. And Kumo's here as well. Euclidean geometry. Okay, so we'll do a little bit of analytical and then we'll do some Euclidean. And then we can find out from Kumo as well if there's something that they want to do. That's the nice part. When it's just a few of you, you can really just tell me what you want to do. Hi Kumo, welcome. Kumo, because the class is quite small this evening. It's actually just 3 of you so far. I don't think many more people are going to show up this evening because I think most people are finished writing exams. But you can tell me, Kumo, what you want to look at. Trigonometry, analytical geometry, Euclidean geometry. Just pop it in the chat and let me know what it is you want to go over. In the meantime, we are going to start with this analytical geometry question that we've got here, because Brandon asked for a bit of analytical geometry to do that. Okay, so we've got 3 points, points G, K, and L, and they're points on the Cartesian plane. And first question is to determine the equation of the line GL. So if we are determining the equation of a line, what is the standard form for a straight line equation? Is Emilio also here? Okay. Pop it in the chat. What is the standard form for a straight line equation? I'll help you get started. Y equals, and then we have something with an X and something else. What is that? Lydia says Y equals mx plus c. Good stuff. Okay, so if we're going to determine the equation of this line, we need to figure out what m is and we need to figure out what c is. So m is our gradient and we have the 2 points G and L that we're working with. Okay, so work out now what the gradient is, and when you have your answer, pop it in the chat. There's your 2 points G and L, and calculate the gradient for this line using G and L. When you're done, put your answer in the chat. Kumo, when we do analytical geometry, we are going to do a little bit of straight line graphs, but tonight's session is pretty much dedicated to paper 2 content, and straight line graphs is in paper 1. So we'll do a little bit of straight line stuff in the analytical geometry, but we won't be going into it that much because this evening we are just ending off with paper 2 stuff, paper 2 revision. So give this one a go so long, Kumo. What is the gradient of GL? Lydia says -3. Sisibo says -3. Let's see. Okay, so we take the y, so change in y over change in x. So you can go 4 minus 1. We could have gone the other way. It doesn't matter as long as you're consistent with your x's and your y's. And then 1 minus 2. That gives me 3 over -1, which is -3. Okay, so let's fill in what we've got so far. So the gradient is -3x plus c. Now we have to solve for c. So what is our plan here? How will we figure out what c is? Does anyone know? You can pop it in the chat if you know. What will be our next step to solve for c? As we work on finding the equation of this line. Saku is also here, Untatile. Okay, so our numbers are growing steadily. How will we solve for C? What is our next step here? Just pop it in the chat. We should know this, everybody, especially since you have all written exams. We're not going to divide, but we are going to sub in a point. So we can sub in either G or L for X and for Y, because that means I'm only going to have C left. So I'm going to sub in G, which is 1 and 4. So that means my Y is 4 and my X is 1. And that's going to be very helpful to solve for C. So we get 4 is -3 plus C. Take the -3 to the other side, we get 7. So C is 7. So then Y is -3x plus 7. So always to solve for C, once you have found the gradient, you sub in one of the points that's on the line to solve for C. You could have subbed in L as well. It would have given you the same thing. Okay, so let's go on. Let's see what's next. So T minus 1/2 and 0 is the midpoint of GM. So let's draw this. Let's make a little diagram. Here's G. The coordinates for G is 1 and 4. Maybe what we must do is make a better sketch where we are actually making a little Cartesian plane. And G is 1 and 4. And point T is minus 1/2 and 0. So that's going to be on the x-axis over here, minus 1/2 and 0. And that's point T. And that point T is the midpoint of GM. So we don't know what the coordinates of GM, what the coordinates of M are. That's what the question is actually asking for, is to determine the coordinates of M. So if that's G and that's T, then M must be somewhere over here for this, all of this to make sense, because T is the midpoint and that's G. So here's M with an X coordinate at M and a Y coordinate at M that we're now going to calculate. Okay, so we've done this a few times. We did it last on Tuesday as well in the other exam question. So how are we going to do this? Can anyone remember? Because we have the midpoint, so we're definitely going to use the midpoint formula. We just need to figure out what the coordinates of M are using that midpoint. I'm going to give you about 2 minutes to work on it, and then we can see how you go. So we'll check back in at 17:16, see if you can look back on what we did on Tuesday. We had a similar question, and we also did many of these when we did analytical geometry in the course earlier on last term. But also just see if you can use your logic. Okay, let's see. So to find this x coordinate at M, normally what we do when we find a midpoint like T, we take the x coordinate at G and add it to the x coordinate at M, and then divide it by 2, and then we get that midpoint, which is minus a half. So we're going to make an equation. We're going to say, take this x coordinate, 1, add it to the x coordinate that I don't have, divide it by 2, and that will give me negative a half. Now we can just solve for this. We can solve for that x coordinate. We times by 2. So 1 plus x at M is equal to minus 1. And that's just timesing by 2 on both sides. If I times by 2 on this side, the 2 just cancel out, and that 2 cancels with the 1 you're timesing by. When you solve for that x coordinate by taking the 1 over to the other side, you subtract it. So minus 1 is going to give me minus 2. And then I do the same for the y's. So I take the y coordinate at G, which is 4, plus the y coordinate at M, and I divide that by 2, and I get 0, because that's the coordinate of the midpoint. Same story, we can times by 2 to get rid of that fraction, and then we're going to take the 4 over to the other side by subtracting it, and we'll get minus 4. So the coordinates of M eventually is minus 2 and minus 4. Okay, just put a thumbs up in the chat if you are happy with that, or if you got it right there where you were doing it. Just put a thumbs up in the chat so that I know that you understand. Guys, I'm asking for thumbs up in the chat. I'm not seeing any thumbs up. If you're not sure, you can put a thumbs down, but then you must ask a question. Right, Brandon's giving us a thumbs up. Everyone else, where you're at? Okay, I haven't heard from Emilio and Kumo and Leah and Mitsaku. Okay, there we go. Right, so let's go on to question 2.3. We have to prove that KM is parallel to GL. When we prove that two lines are parallel, what is it that we need to calculate? What do we need to calculate and find to be equal? Put it in the chat if you know. We've done parallel lines many times. The gradient, well done. Brandon, we need to calculate the gradient. And what do we know about the gradients of parallel lines? Are they equal? Are they -1? Are they something else? What do we know about the gradients of parallel lines? They're equal. That's right. So we're going to check what is the gradient of Km and what is the gradient of GL. Okay, I'm just going to go fetch these points over there so that we can see them where we are working. Doesn't want to cooperate. Oh, annoying. Okay, I'm just going to write them down then. Okay, G is 1 and 4. L we worked out is, or we were given 2 and 1. And K is -3 and -1. Okay, so there you go. Now you have everything you need. Calculate the gradient of Km and the gradient of GL and see if they are the same. When you get your answer, pop it in the chat. This is 3 marks, so we'll have 3 minutes until 25 past to finish this question. If you have the gradient for Km, put it in the chat. The gradient for Km. Oh, point M was over there, just above, -2 and -4. Okay, Brandon says it's -3. Let's get some more answers from everyone else. This is not difficult, guys. You're just working out gradients. You've done this many times, unless you are snoozing through the lesson, which might be the case. Hey, Miss Mimi.
Yeah, it could be. What is everybody else getting? Please share your answer.
Let's share your answer in the chat, please. What is the gradient of Km?
What do you think, Ayanda?
Grade 9s could do this. Okay, so Sipo says -5/4. Grade 9s could do this, and you guys are on your way to grade 11. Okay, Km, we're going to do the change in y over the change in x. So -1, here's k, there's m. So I go -1 minus a -4 over minus 3 minus 2. Okay, so just be careful how you, when you work with your points, so that you're consistent. And if your ky goes first, then your kx must go first. And I think that might be where the problem is, Asipo. So just double check. So minus 1 plus 4 is 3. And then minus 3 plus 2 is minus 1. So I get minus 3. Well done, Brandon. You got that one right. And then we don't have to go through all the trouble to actually work out GL, because we did it already. GL we did in question 2.1, and it was also minus 3. So you can just write that it's minus 3, and then just write a short sentence here to say that the gradient of Km is equal to the gradient of GL, not G4, GL. So used to making 4s. Therefore, Km parallel to GL. Okay. Last one with the, don't think I rubbed this out. Let me just quickly erase this. Last one with the analytical, and then we'll get a chance for some Euclidean, because I think that's what someone else asked for. So now we're gonna, the question asks that we must show that Km is equal to GL. So we just did Km parallel to GL. So what are we gonna do here? Km equal to GL. What are we gonna work out? Are we gonna work out a midpoint, gradient, distance? What are we gonna work out? Pop it in the chat. Distance. Yeah, that's right, Brandon. Distance. So for Km, we're going to calculate that distance. I'll write the formula down for you here. And this, you're going to use the same for GL. Let's just go get those points so that we can see what we're working with. These points here. This is not cooperating with me this evening. It's not letting me do snips or highlighting. Okay, here we go. There's all our points. And let's take the next 2 minutes. Let's quickly work out these two lengths. And as soon as you have them, pop them in the chat. Then I know you're done. Calculate the length of Km and the length of GL, or the distance of Km and the distance of GL. When you have an answer for Km, put it in the chat. There should be a square there by the Y's. So that should be your substitution. Then you just need your calculator to do Km. I'm waiting for someone to put it in the chat. What is the answer for Km? And then also, what is the answer for GL? Let's see, guys. What do you get for Km and GL? It can't be taking this long. It's going to be a matter of just punching into your calculator. So put an answer in the chat. Hey, Miss Nelly.
Because we've already substituted everything for them. So it's just putting it in their calculator. Oh, here's on chat.
There's Untatileg square root 10. That's good. Thank you. And what do you get for GL? Untatile? Olia, Olidia. Sisipo says square root 10 as well. Good stuff. Right. So we've got Km and GL. They're equal in distance or in length. So that's actually this last question. It asks what type of quadrilateral is GKML and why? And if you look at it, we've got Km equal to GL and Km parallel to GL. So this is actually a parallelogram because one pair of opposite sides is parallel and equal. Good. Let's see. We've got about 10 minutes left and we're just gonna maybe try a little bit of Euclidean geometry. Now, I think it was Sisipo asked for Euclidean geometry, if I'm not mistaken. Okay, just here you go. So I'm going to give you a few minutes to have a look at the question as always. Read through at the top what is there, make sure everything is transferred to your sketch. And then you can start working on the first two questions. Give a reason why WV is equal to VR, and we have to prove a congruency as well. Okay, but first read, have a look, and go on your fact-finding mission. Find things that are equal. Is there midpoint theorem in here? Are there some quadrilaterals, etc.? There's definitely some things written in the introductory part that's not shown in the sketch. Okay, just want to make sure we managed to finish this question before the end of the lesson. Okay, so we read in the diagram below, P is a midpoint, and that's shown. So you can highlight that. And V is on WR such that VP is parallel to RQ. So that's great because that means you've got midpoint theorem. So WV will be equal to VR. And that's the first question that they ask, is give a reason why WV is equal to VR. And that is because of the line from midpoint parallel to second side. Parallel second side. Okay, what else is there? PV is produced by its own length to S. PV is produced by its own length to S, which just means that PV is equal to VS, as is shown on the sketch. PW is produced to T and ST drawn. Okay, so that doesn't really make any difference. Now, the next question is 8.2.2a, triangle VWP. We need to prove it congruent to triangle VRS. Okay, so that's VRS. VRS, that's going to be pretty straightforward because we've got the purple sides that are the same, and then we've got the two marker sides that are the same, so VP equal to VS, and then we can also do an angle V1 equal to angle V3 because of vertically opposite angles. So I'm going to write the congruency proof over here, and that's in triangle VWP and triangle VRS. The first thing I'm going to say is that PV is equal to VS. That's given. Then for 2, we're going to say that VW or WV is equal to VR. And the reason there is line, you can use converse midpoint theorem as well, or you can say line from midpoint parallel second side. And then our last one is V1, angle V1 equal to angle V3, and that's vert op. So we can say that triangle VWP is congruent to triangle VRS because of side angle side. Now, because of side angle side and because of congruency, all angles and all sides in those two triangles will now be equal. They are now exactly the same. So we can go right ahead and mark SR also as a one stripe because of the congruency. So we've got the congruency. Then for 2 marks, we have to say or prove SWPR is a parallelogram. So SWPR. So you actually have to draw it in a bit. If you had so that one there, they want to know if that is a parallelogram. And if we look at it, we can't really do opposite sides parallel. We can't really do opposite sides equal, but the diagonals are nicely drawn in for us, and the diagonals are bisecting. So if you look at SP and WR, those are all bisecting. So that's one of the ways to prove, if you remember those 5 ways of proving a parallelogram. So we can say SWPR is a palm because the diagonals bisect. Okay, and then PQRS is a parallelogram. So PQRS is a parallelogram. Can we say that PQRS? Does anyone have any ideas why this one would be a parallelogram? We can do one pair of opposite sides parallel and equal, or we can do opposite sides equal. So we've got one pair of opposite sides equal. Can we prove that that SR is parallel to PQ? Well, we can from our question that we just answered. This will be parallel, and because these are all straight lines, PQ is part of that line, so PQ is parallel to SR. So we can say that PQ parallel to SR, and that is because of opposite sides of SWPR, and PQ is equal to SR. That's just proven from our previous work with congruency and all of that. And therefore, we can say that PQRS is a parallelogram, one pair of opposite sides parallel and equal. Parallel and equal. Okay, you're welcome to take a screenshot of that if you want. And that's it, finishing right on time at 17:45. There is a quiz, one last quiz this evening on paper 2 stuff. So you can go for it. Ms. Nelly is going to post that in the chat, the link to that in the chat. And then that's it for the year, great teams.